today's lesson we are going to be looking at reviewing polynomials. So again, this is something that you probably would have gone over in grade 10 and a little bit in grade 9. So you should remember some of this, or if not, hopefully it starts to ring a bell as we go through it. So what are polynomials? Well, polynomials are expressions that are made up of a finite or basically fixed number of terms separated by addition or subtraction. So terms separated by addition or subtraction, that's a key thing to what a polynomial is. Now there's different classifications of a polynomial depending on how many terms there are. Monomial is one term, binomial is two terms, trinomial is three terms, and then for anything else or anything above three, you use poly or polynomial to represent them. The terms of polynomials can have two types of things in them. They can have variables raised to whole number exponents if necessary, so letters with exponents, and constants, or basically numerical coefficients. So a term could have any combination of those, whether it's just a variable and exponents, or just a variable with no exponent, or a constant, or a variable and a constant. So it could be any combination of those. Here we see an example of a polynomial. Well, specifically, because there are three terms, and we can see them because they are separated by addition or subtraction. So here we see one term, here we see another term, here we see a third term. So it's three terms, which means this is technically considered a trinomial. And when we're looking at the different terms, we can see some of the different combinations. We can see in the first term, we have our coefficient or a constant, or numerical, actually better described as a numerical coefficient. And the reason so is because in that same one, we also have a variable with an exponent. We can see in the second term that again we also have a numerical coefficient of 5 or negative 5. We can see that we have a variable term there as well. There is no exponent, or what you can argue is that there is an exponent of 0, and we will touch on those exponent laws that you would have learned. We will review them a bit in a later part of the course. And then lastly, we have just a 4 or a numerical coefficient. However, there is no variable, so we could classify this as a constant. So a constant is just a number on its own. There's no variable here. So again, you can see the different combinations that you may find when looking at polynomials. One thing to keep in mind when working with polynomials, terms that have the same variable factors. And what we mean by that is the same letters or variables with the same exponents. If we have terms that have the same variable factor, we would consider them like terms. Now hopefully that term or phrase rings a bell. We'll look at a little example here, looking at these two pirates, looking for the things that are considered like terms. So you can see the chests are common between them. You can see the bags of coin are common, as well as the individual coins. So if I was to add their two bounties or stashes together, I would add up the parts that are the same. So we would say that they have, say, 4 chests. We'll say 4C plus 4 bags plus 4 and 5. And you say 9. Don't want to use C again because we've already for coins or change. I think pirate coins maybe are called doubloons or something like that. So maybe we'll use D instead. So we can use or collect like terms when we're looking at like terms. Now this is kind of a very simplified example, but this is the general idea that we're looking at. And we'll look at a couple of examples as we go through in practice. So to simplify a polynomial expression containing like terms, basically we find the sum of their coefficients. Again, remember we defined a like term as having the same variable factor. So a helpful thing to do is when you go through, look for your terms that are considered like terms. Same letters, same exponents. So here we have an x and an exponent 2. Where else do we see an x and an exponent 2? There's only one other term here. So those are considered like terms. You might say, well, this one has an x, and there's an x here, which is true. However, the exponent is not the same. If we look at the next term with just the x, there is only one other term that has just an x with no exponent visible. Those are like terms. And lastly, when we look at the coefficients or the terms that have no variable, they are considered like terms as well because they have the same variable factor, which is the fact that they don't have one. There are no letters there. So now that we've identified the like terms, we can go through and collect them. So basically the way that works is we add the coefficients or the numbers in front. Basically you could think of these variable factors as their identifying thing or the items that we're adding, right? We look, maybe it's x squared represents chests. So we have 2 chests, take away 1 chest. The reason I'm saying take away 1 is because when we don't see a coefficient in front, we assume that it's 1. So if I have 2 take away 1, I'm left with 1 x squared, or one of those items. Moving on to the next set of like terms. 3x plus x. 3 of something plus 1 of something gives me 4 of something. And then minus 4 plus 9, just 2 numbers. Negative 4 plus 9 gives me positive 5. So I'll just highlight those again to show you where they're going to or where they came from. So hopefully you can make those connections. So that would be collecting or simplifying that polynomial. Next one, again, a little bit longer because there's more terms, but go through the same steps. Find your like terms. So we found a variable factor that has x and an exponent 3. Go through, find the other ones that have x and an exponent 3. Once you're done, move on to the next variable factor. X and an exponent 2. There is no other term that has an x squared, which is fine. It just means we're not going to add anything or subtract anything to it. Next term has an x. We'd see one other term that has an x. And lastly, we just have a constant on its own or a term that has no letter or variable. So again, there's no other terms, so it's just on its own. Now we're going to go through and collect our like terms. So focus on the ones that are the same. So 10x cubed minus 4x cubed. 10 of something minus 4 of something gives you 6 of that item. Move on to the next term. Negative 14x squared. There is no other term that you need to add, or there are no other like terms, so we can just bring this down or carry this down. We're not going to change it. Next, we have our terms with the x. So 3x plus 4x, 3 of something plus 4 of something gives me 7 of something. And then finally, negative 6 is just on its own. There is no other term that has no constant. So we just carry it down similar to what we did with this x squared term. So again, you can make the connections of where these terms came from or how we kind of group them together. If we have to add polynomial expressions, what we're going to do is remove the brackets and collect like terms. So that's all we're going to do. All we're going to do when we're adding polynomials, again, we can see here we're adding polynomials together. This is a trinomial plus a trinomial. All we do is we remove the brackets. It will help to rewrite this in some cases. So 4x squared minus 7x minus 5 plus 2x squared minus x plus 3. So all I did was just rewrite the entire expression without brackets. But again, this only works, or this only really applies when we're adding polynomials. When we're subtracting, which we'll look at later, there's a different step that you have to do. So now that I've removed the brackets, now I can start looking for like terms. So I have an x squared term. I go through my other terms. I find another x squared. I don't see any more, so I move on to the next one. An x, I look through, I find another x, and then the constants, the ones that don't have terms. Actually, let me go through and just highlight everything, because now rewriting it, you can see that sometimes you might highlight the coefficient rather than a constant by mistake. Now that you've identified your like terms, we have to go through and collect them. So 4x squared plus 2x squared. 4 of something plus 2 of something gives me 6 of something. Minus 7x, or negative 7x, minus, again, no coefficient, we assume that it's a 1. So minus 1x. Negative 7 minus 1, we're at negative 8x. Our two constants, negative 5 plus 3, just adding integers, we're at negative 2. So again, collected our like terms. So now we've simplified our expression, or we've added the two polynomials together. If we're subtracting polynomial expressions, so if we're subtracting them, we have to do something different. When we're subtracting, we remove the brackets in the second expression by multiplying each term by negative 1. Once we do that, we collect like terms. So we can drop the first set of brackets. So we have 4s plus 5st minus 7t squared. Now, in order to drop or remove the brackets for the second expression, I need to multiply everything by negative 1. So if I go through negative 1 times, so again, looking at this term, negative 1 times 6s squared is negative 6s squared. Let's look at the next one. Positive 3st. Negative 1 times positive 3 is negative 3st. And move on to the last term, negative 2t squared. Negative 2t squared times negative 1, negative 2 times negative 1, two negatives, is positive 1. Or sorry, not positive 1, positive 2t squared. So now that I've multiplied every term in the second bracket by negative 1, I no longer need the brackets. Now there is a quick way to kind of do that, because what's actually happening when you're multiplying each term by negative 1? Well, when you multiply by negative 1, so multiplying, oops. So when you multiply by negative 1, all it does is it just changes the sign. So if it was positive, it becomes negative, and it's a negative, it becomes positive. So that's all that's happening when you're multiplying by negative 1. So all you have to do, a quick way, rather than going through those steps and multiplying, just change every sign to negative 1, or to the opposite, sorry. Now that we've done that, we can look for our like terms. So we have 4s. Look through, do we see any other s terms? No, we do not. 5st, So we look for terms that have an s and a t with it. So we do see one of those terms. Look for a term with a t squared. We see a t squared, and then look for, there's only one term left, so that is going to be on its own. Now that we have that, we can collect our like terms. So we have 4s, there's no other term to add, plus 5st minus 3st. So because there's two variables, it doesn't really change what we do. We're still adding the coefficients. So 5 and negative 3, or 5 minus 3, is 2st. Negative 7t squared plus 2, negative 5t squared, and negative 6s squared is going to be on its own, because again there are no other like terms, or there are no like terms to add to it. So again, one smaller step by multiplying the negative 1 through. So we can just kind of show that. This multiplied by negative 1, this multiplied by negative 1, and this multiplied by negative 1. So that's how we got the change in those signs. So that's the one extra step that you have to do when you're subtracting polynomial expressions. The last thing, to multiply polynomial expressions, we remove the brackets using distributive property. And that's kind of what we did in the last one, and you may remember that term as well. So after we use the distributive property, if you don't remember, we'll go through it, don't worry, you collect like terms. So the final step is always collecting like terms. So it is important that you understand what like terms are, or how to define them or differentiate like terms from other terms in your polynomial. So we'll start off with a simple example. We have two binomials that we're multiplying together. Right, remember, when we have two brackets side by side, we assume that there's multiplication between them. If there's no sign or operation visible, we assume it's multiplying. So we have 2x plus 5 times 3x minus 4. I'm just going to rewrite it. Now we need to use distributive property. Distributive property, you might also know it as the FOIL method in some cases. Is multiplying every term by each other, or multiplying all the terms together. So we'll kind of go through and visually just do that. So we have 2x, we're going to multiply that with the 3x. So we have 2x times 3x. We're then also going to multiply 2x by negative 4. So 2x times 3x is the first multiplication, plus 2x times negative 4. Next, we look at the next set of term. We have 5. So we're going to add 5 times 3x. And then lastly, 5 times negative 4. So every term is multiplied with the other. Right, we have 2x times 3x, 2x times negative 4, 5 times 3x, and 5 times negative 4. Now you might say, well, why not 3x times 2x and negative 4 times 2x and so on? And again, that's because when we're dealing with multiplication, the order doesn't matter. So you could switch them around and be the same thing. Now we can go through and multiply. So 2x times 3x. When you have a mixed term, or you have coefficients and variables, multiply the like things together. So multiply your coefficients or numbers together. 2 times 3 gives you 6. X times x gives you x squared. For the next one, 2 times negative 4 gives you negative 8. And x doesn't multiply anything else, so it just gets carried along. 5 times 3x, same idea. 5 times 3 is 15. and you just carry the x down. And then lastly, 5 times negative 4 is negative 20. Now that's the end of the distributive property. You've multiplied everything. So then the last step is to collect your like terms. So if we go through and look, 6x squared, there's no other term within x squared. 8x and 15x, they both have an x. And then we have, oops, that's not a good color to use. And then we have negative 20 on its own. So now we can go through and collect those like terms. 6x squared, it's on its own. We have the minus 8x plus, let me just go back to original color, sorry. 6x squared minus 8x plus 15x minus 8 plus 15 is positive 7x. And then we have the minus 20 on its own. So once we've collected our like terms, that is the end of simplifying our polynomial or multiplying this polynomial. So there is a few extra steps. Again, I've written down a lot more. You may be able to jump from here right to here if you're comfortable with this. If not, I would definitely recommend going through these steps. Show the arrows, show the actual multiplication, and then go through it. If you find that sometimes you get lost or you forget things, it definitely helps to write it all out. For B is a little bit longer because again there's more multiplication going on, but there's less terms in terms of what we're multiplying. It's just one term multiplied through, so it might be a little bit easier. Here we're just going to go through and show some of the multiplication because there is a lot. So we won't rewrite it. Again, we're going to assume that between the 2x, or between, you could say the coefficient and the bracket, here, here, and here, we are multiplying. So that means 2x multiplied by the bracket, negative 3x multiplied by the bracket, 3 multiplied by the bracket. So 2x times 4x, I'm just going to write out the full thing. Actually, no, for sake of, yeah, I'll write it out. Then we have the next one, 2x times negative 2. So we're adding 2x times negative 2. We're always going to be adding whatever we multiply. The signs will work itself out when we do the multiplication. So we're going to add negative 3x times x. And we're going to add negative 3x times negative 5. And then we're going to add 3 times x, and then 3 times 6. I'm going to go through and simplify each one now. 2x times 4x is 8x squared. 2x times negative 2 is negative 4x. Negative 3x times x is negative 3x squared. Negative 3x times negative 5 is positive 15x. 3 times x is 3x, and 3 times 6 is 18. So that's the end of the distributive property. What we need to do now is go through and find like terms. So again, x squared, there's another x squared, there's a 4x, 15x, sorry, negative 4x, a 15x, a 3x, and then we have a constant on the end. Once we found our like terms, we can go through and collect them. 8x squared minus 3x squared, 8 minus 3, 5x squared. Negative 4x plus 15x plus 3x. So negative 4 plus 15 is 11, plus 3 is 14. So we have plus 14x. And then lastly, 18 is just on its own. So I've collected like terms now. I've simplified it as much as I can. So I've multiplied that expression. So there are two more. I'll let you try these on your own. I'll give you a couple hints to help you through. When you have brackets within brackets, you work on the innermost brackets first. So work on the innermost brackets first. And then for D, just be aware of the exponents. Understand what the exponent refers to. Right, so you might have to follow BEDMAS. So I'll let you try these on your own. These will be a little bit tricky. So you can pause the video and try it on your own, or you can just kind of wait and just carry through the video, and then we'll go through the answers together. So going back to these last two examples, they definitely took a lot longer than some of our other ones because they're a lot more complex. But again, as long as you take your time and work through it and based on what we've just kind of learned, hopefully you made it through. So let's look at C first. So what we did first was we worked on the innermost brackets. So we worked on the multiplication on the inside first. So again, we used the distributive property. We did the 2x, or 2 times x, 2 times negative 5, and then the here, what we did was we included the negative with the 4 when we multiplied it through. So negative 4 times 2x, negative 4 times negative 3. We did all that, we simplified it down to here, and now we could have left it and multiplied the negative 3 into this bracket. We would have had to have multiplied negative 3 by more terms, so I simplified it here so that it made it a little bit easier. Now, you may not have simplified it, which is okay. You would have had to have simplified or collected like terms after you multiplied, but either way, in the end, you should have still made it down to 18x minus 6. So again, there are some steps that you can kind of switch around, but in most cases, you do want to follow a specific order, very similar to order of operations. Now D is a tricky one because there are a lot of things we have to take into consideration. The first thing you should have recognized was the exponents. So the exponents mean it's the same thing multiplied by itself, or it's something multiplied by itself. In this case, what's being multiplied by itself is the entire bracket. So we have the 2x plus 3 multiplied by itself, which we can see here, and the x minus 5 multiplied by itself, which we can see here. So again, we're still following BEDMAS to some degree. Brackets, exponents, division, multiplication, addition, subtraction. So we're still following that to some degree. So I did the exponents first. I rewrote it out and I multiplied those terms through, especially in the second term. In the first one here, I multiplied the 3 through first. When I have 3 terms multiplying each other, the order doesn't really matter. So what I mean by that is I had 1 times 2 times 3. I can do 1 times 2 first. 1 times 2 is 2, and then 2 times 3, which gives me 6. Or what I could do, if I did 1 times 3 times 2, 1 times 3 is 3 times 2 equals 6. Or let's say I did 2 times 3 times 1. 2 times 3 is 6, times 1 is 6. So when we're multiplying terms or multiplying things together, the order that we multiply it in doesn't matter. The only reason I broke it down is because I had the exponents. So I couldn't just multiply the 3 in first without taking care of the exponent. So I multiplied the 3 in for the first half. The second half I multiplied through, because again, they're separated by that subtraction, so that I would deal with later. On the right side, once I multiplied everything through, I started to collect like terms to make it a little bit easier. And highlight it, so we can highlight it down here, just to make things simple as I went along. On the left side, after I multiplied the 3 through, and simplified. I then multiplied that through to the second bracket, so a lot of multiplication going on here, and a lot of brackets. So then I had two sets of brackets to multiply. On the left side, the right side was already simplified, so I didn't have to worry about it till the end, where I had subtraction between two polynomials. So the left side and the right side. So that subtraction didn't get used up yet. It's still there. You can see that it stays there all the way through my expression until the final step where I want to get rid of that. Again, by getting rid of that subtraction, I need to multiply everything in the second bracket by -1. Or, as we mentioned, all we're doing is we're just changing the signs. So that's this second last line here. The first bracket stays the same. Brackets are dropped. Second half, all the signs change, so -x squared. -10 becomes +10. +25 becomes -25. And that very last step, collect like terms, and we end up with our final answer. So this is definitely the most complex one that we are probably going to work with when we're going through. But again, as long as you're following all of those steps that we looked at today, hopefully you're able to make it through. So there's some more practice, and again, hopefully this does now seem a little bit more familiar. If not, again, make sure you're working through the review to refamiliarize yourself with these concepts.